Hello everyone, welcome back to ExpertFunda. So today we are going to understand rearranging fruits problem from the Leetcode, and this is a really tricky problem. So I will break it down in very simple steps so you will understand what it is asking and why the solution will work, right? So the question is saying that you have two fruit baskets, okay? Means you have two fruit basket, right? Means two baskets of fruits you can say that contains n fruits, right? So each basket contains n fruits, okay? And uh and the basket are basket 1 and basket 2, understand? So it represents, the basket represents what? The cost of fruit in each basket. You want to make both basket equal, right? Means if I say basket at some value, let's suppose this is basket at I, right? So if basket at I is nothing but what? It is saying a cost of fruit in each basket. Means each index of the baskets, right? Either basket 1 or basket 2 is the cost of fruit at index I or index J, we can say, whatever the index is there. Okay. Till that, just we can say the each index or each elements uh, of the basket is nothing but the cost of fruit at the index I, either in the basket 1 or basket 2. Understand? Now it is saying you want to make both basket equal. So our job is to make the both basket equal. Means we want to make both basket identical after sorting by swapping fruits between baskets, right? Means when both basket are identical, right, we'll do sorting, swapping, right? That we will do. So between the fruits, between the basket, we can say, okay? How? Let's understand here. It is saying choose indices I and J. So if you are choosing an indices, two indices, right, in I and J, you can swap what? The ith fruit of basket 1 with the j fruit of basket 2. And this is the function given. Like, let's, you can choose that and then swap that. And the cost of swap is, you can calculate through this function. This function contains two arguments. Each element of basket 1 at index I, element at j at basket 2, we can say, right? So this is called the cost of the swap. Okay, means if we say cost of swap is equal to what? The mean of cost of fruit from basket 1 and cost of fruit from basket 2, right? And what is our goal? Our goal is to find the minimum cost to achieve identical basket, or will return -1. This is the problem we have given. Let's understand through this example, right? So you can pause this video, you can read this again, right? So we'll understand clearly. Okay, so let's understand in very simple term what we have given, right? We have given two baskets, right? Basket 1 and basket 2, right? And this is nothing but the cost of the fruit at index I, and this is nothing but the cost of fruit at index 2, right? We want to do what? We want to make both identical after sorting or swapping the fruits between the basket, right? And you can get the cost of the swap. So we have to return what? Minimum cost when we will swap it, right? So very first step, you should understand what we have given, what is our operation should be there, where the very first should be the swapping. We will do the swap, right? Very first step we will do what? Swap means we will pick one fruit from basket 1. Let's suppose there is a basket and there are many fruits we have given. There is another basket, there is many fruits are there, right? So we'll pick one of the fruit from here, right, from the basket 1, and one fruit from basket 2. Can we say that, right? We will get one basket from we will pick the first fruit from basket 1 and second fruit from basket 2, and then we'll do the exchanging, right? We will put here this one and this will put here, right? We'll do the exchanging. Once this is done, that is called swapping, right? So this is the question saying. Another what question saying that after uh, mm, uh enough swapping that is done, right? The sorted, if we'll do the sorted, basket, let's say basket, it should be equal to what? Sorted basket 2. This is 1, this is 2. So both should be equal. Understand? This is the question is saying that. Means if we'll try to understand what are the conditions we have given, right? What are the conditions we have given? Very first, the condition is saying that was here. Yes, equal, right? Equal. We have to do what? Equal total counts per fruit, right? Equal total counts per fruit. Fruits, fruits. Okay. So very first, the important condition is equal total counts. If we'll take, right, the count of both, right, so total count per fruit, if the total count of any fruit in the basket 1 or basket 2 is odd, let's suppose if we'll take the total count, just think, if we'll take the total count, let's suppose in the basket 1 b1 we can say, and basket 2 b2 we can say. If we'll do the count, right, that is sum, and if it is coming odd, right, if it is coming odd, is it possible? No, right, it is not possible. What we should think that this is our important condition, where when if the total count is becoming the odd, right, if it is becoming odd, it means it is impossible. So this condition is nothing but impossible condition. So you should take care of these conditions also in your mind, because if you're not understanding the edge cases, you are not able to solve the problem, because this is a hard problem, right? So you have to think like that what is the important conditions we have given in this problem. Very first, when it is not impossible, when it is impossible, it is impossible when the total count means if the total count of any fruit in basket 1 and total count from basket 2, if you do the total, right, total of any fruits in both basket, total fruits of any fruits, total count of any fruits in b1 or b2, if we'll do the plus, it will be odd, and if will be odd, it is impossible. We cannot distribute evenly, either in this one or in this one. Somewhere we will left something, right? Some counts you can say. Then another condition is also saying that we only swap extra, right? So extra fruit, we only swap extra. Understand? The very first condition was equal total counts per fruits, right? Per fruit. Another saying, we only swap the extra, means when extra fruit in one basket must be swapped with the extra fruit from the another one, right? If any extra fruit is there, right, in basket 1 b1, right, it should be it must should be swapped with the what, b2 from the another one, right? This is the third condition we have. Second condition we have. Then we have to do what? The minimum swap, right? Minimum swap cost we can say. Okay. Very first it was equal total count. If it is coming odd of any fruit, right? In both it is impossible. Then if we have only to swap the extra, right? It means extra should be extra fruits in the one basket must be swapped with the extra from the other one, b1 or b2 we can say that. Then we have what? Minimum swap cost, means each swap cost is what? Let's suppose, let's call it mean a and b, right? So each swap cost is, let's suppose, called a and b. A and b are the a fruit in basket 1 and b fruit in the basket 2, right? So if we take this mean, it is nothing but the swapping cost, right? So each swapping cost, let's suppose call a and b, mean of a and b, But sometimes it is cheaper to use two swap with the a smaller fruit overall. That is called indirect swap, we can say. Let's suppose if we can say cost, right? We can say 2 into, let's say, called global mean. There is some value is there, and we'll say global mean, we will say. Okay, right? So if sometime it is become cheaper for you, right? You'll understand through the example, don't worry, right? So what will happen if it is cheaper to use two swap, right, with the smaller fruit overall, right? So we'll just say it is an indirect swap, and for the cost we'll say just 2 into the global mean. What is the mean is there, just you multiply it, you will return it. That is called minimum swap. Okay, so I hope you understands, but let's understand the example now. Let me clean it. Okay, so very first what we have given, see in the example one, basket one and basket two, right? So if I represent the basket in the form of array 2 2 and 2, 4 2 2, like that we can say that. Okay, so this here nothing but basket one. Okay, I'll take basket two here. So this we have is 1 4 1 and 2. Can we say that these two baskets we have given? Okay, so if this is okay, give me 1 second. Okay, very first, if we will count total fruit b1 and b2, from the b1 and b2, how many type of fruits we have here in the here? It is, here we have two type of fruit, 2 and 4, right? And here we have 1 2 and 4. Here we have three types of 4, here we have two types of 4 fruit, right? Right, let's combine this. So how many times 2 is coming? It's coming 3 times here, and here 1 is coming 2 times, correct? Like that we have given. But if you observe the fruits, let's suppose I'll say count total fruit, let's suppose I'll say, because we want to combine this count, right? Let's suppose we have fruit 1. Fruit 1 count is what? Is 2, that we are seeing here. We want to combine it, right? Very first, what we should do? Combine means total fruits. Very first step, right? Very first step, what we should do? Total fruit. So for that, we'll say the fruit 1, how many counts we have is 2. Then let's suppose say for fruit 2, what is the count we have is 3. Then we'll say for fruit 4, how many counts we have? 1 is here and 1 is here, means we can say 2. Can we say that? Okay, I think I did mistake. Here we have what? 1 2 and 3. It is 3, and here it is one more is there, so we can say this is 4, right? Now if we'll do the sum, right, what we will get here? 2 2 and 4 is 8. Means if we'll do the sum of this value, how many fruits we will get here? We'll get total count is 8. Actually each fruit, the difference is difference between the basket, if you'll find, right, right, so that we'll see later. But just understand, if we'll combine this, we are getting what? 8, right? It means for each fruit, if we combine, the count must be even, right? So we are getting what? This is also even, this is also even, this is also even. All these fruit f1 f2 and f4, if all are coming what? This is even, this is also even, this is also even, right? So all are coming even, right? It is, after combining, the count must be even. If it is even, because the final distribution, right, gives you from the both basket is giving you what? Equal, right? It is giving you not called equal, but you can say even, right? Both basket. So it is possible, it is not impossible, it is possible, right? So what we should do next? When it is possible, what we should do means we have to compute extra element difference. Means we have to find the difference now. Let's understand how to find the difference. Let me clean it. So what we have seen total is coming 8, right? That we have seen. Now in the next step, let's suppose we'll compute extra, right? How we are going to compute extra? Compute extra element. How we are going to do that, right? Means we have to find the difference. Can we say that? If we want to find extra element, we have to find the difference, right? The difference will get from, let's suppose called difference from the basket 1 count minus basket 2 count. Can we say that? Count of basket 1, count of basket 2. If we'll do the minus, let's suppose for fruit 1, we have what? F1 is not there. Means 0 minus 2 is coming minus 1. Minus 2 coming minus 2. And this is, we have 1 extra in basket 2, right? In F2, if you'll call, we have how many we have? 2. We have in basket 1 is 3, and in basket 1 we have 1. We are getting 2. Means we have what? How many? 2 extra we have in P1, right? In the basket 1. Similarly, for F4, 1 minus 1, right? Can we say? Sorry, 1 plus 1 is 2, right? And minus 0, we can say. For 4, right? Yeah, 4. Minus will take 4 now, right? It is 0. Okay, so we'll say it is balance. Okay, now prepare the extra from basket 1. What is we have? From basket 1, extra is 2. From basket 2, extra is 1. So we need to swap 1 2, let's suppose 2 and 1 like this. Can we say that? Very first step, we have computed the total. We find the it is possible or not. Once we found that, we find what? Compute element, and when we make the difference, we found what is the extra. If you in B1, if you say, if you want to prepare the swap, extra from basket 1 is 2, and from basket 1 is 2, and basket 2 is 1. Then we only need to swap 1 2 and 1 1, right? If we'll do the swap, right, 1 2 1 2, there is only 1 2, and there is only 1. If we'll do the swapping, right, we need to swap only these two, right? 1 and 2 and 1. It means if I'll say, if we find the next step, let's suppose we'll find the minimum cost, right? This is 2, let's suppose call this is 3. The next step, let's suppose call find the mean cost. How we're going to find the mean cost? So we know the direct swap will do 2 and 1, right? So there will be a mean cost, let's suppose 2 and 1, right? Like AB. So alternative via the smallest fruit, global mean is, let's suppose, is 1. That we are talking about global mean will take 1. Okay, just you multiply 2 into 1. What it give you? It is more expensive, right? So we choose, just do direct swap, and we'll say choose direct swap. We need direct swap, and we'll take 1. That you can see visually. We need only one swapping, we'll do the only one swap. So sometime we don't need to do 2 into 1, like global mean we equal to 1 will not take, right? Because it become more expensive. So better choose direct swap, and we'll say return 1. I hope you understand. So after the swapping, if you'll say, give me one second, let me clean it. So once this is done, means we got the minimum swap is 1, right? After the swap, right, after final swap, what we should say? Both baskets are sorted, right? So if we'll say basket 1, it is sorted is 1 2 2 and 4, because we have did what? We have did sorting and swap, both we have done. So it will look like this, because this is nothing but sorted one, right? Then we'll do B2. So B2 is also sorted. Can we say that? It will look like how? 1 2 2 and 4. Once this is sorted, it will look like this. So both are looking good or not? Both are equal good, right? Because we did swapping. Once we did swapping, we can say, because the minimum cost, if we'll do the swapping for this, right? If we'll do the sorting, once this is sorting, all the 2 will come here, right? And the 4 will go here, right? Means if we'll say it was how 2, 2, 2, and 4, and it will become what? 1, 1, 1, 1, 2, and 4, right? This was the after the sorted was, it was right, both. So if you represent, this is okay, this is also okay. Only problem is what? Here we have 2, 2, 2, 2 we have, and here we have 2, 1 is there, right? So if we'll do the swapping, these 2 with this one, right? And we have to make one swap extra is here, right? So it will become what? 1, it will 1 will come let's suppose this 2 will make this one swapping. Once this is swap, it will become this one, right? And that is why we have gone through all those steps swapping, right? Minimum swap, we'll do the direct swap, otherwise we will choose alternative swap. So alternative swap where the smallest fruit is, we have taken what? Global mean, and global mean was, let's suppose, 1. So 2 into 1 is what? It become 2, and it is expensive, so we'll not do that. We'll do the direct swap. We choose the direct swap, just we make it, and it is sorted. It will look like this one. I hope you understands. So in this case, uh, what will be our answer? Our answer will get 1, because we are choosing the direct swap. I hope you understand. Okay. Now let's understand example 2. Let me clean it. Okay. So very first step, we have given these examples, right? B1 and B2. See, if we will represent this, right? Let's suppose I'll write here 2, 3, 4, and 1. This is example 2, and we have B1, basket 1. So basket 1 contain like this one. Let's take basket 2. It is having the value. Let's take a smaller one. It is what we have 3, 2, 5, and 1. Okay. So this is B2. Okay. So very first step, what we need to do, we have to count total frequency of each character. Each character, not its fruit, right? We have to do what? Total count of you can say as a frequency of each fruit in the this one. So let's combine the basket 1 and basket 2, right? What we want to do is we want to count what you call combine the count, right? How? B1 plus B2, right? So the fruit, let's suppose the fruit 1 is, this is fruit 1. So fruit 1 coming how many times, right? Check here. This is 1 and this is 1, right? Means it is coming 2, 1 in each, either here also and here also, right? So we can say the fruit 1 is coming how many times? 2 times. Similarly, I will take fruit 2. Fruit 2 is coming how many times? Here is 1 time and here is 1 time. It is coming 2 times. 1 in each basket, 1 in each basket. Go for the fruit 3. Fruit 3 is here and here. Both coming is 2. This is also fine because each contains only 1 times. Okay. Now coming to 4. 4 is coming 1 times. This is the problem, right? We have only in B1 where it is there. I'll say that. I hope. Okay, one more is left. The 5. It is also 1 only in B2, right? Means if you combine all these fruit individually, right, if you see the frequency of each fruit, you will observe like this. So these are the fruit 1, fruit 2, fruit 3, fruit 4, and fruit 5, and these are their frequencies, right? So now what we need to do, we need to check the what are the even is there, right? So if you say to make both basket identical, each fruit's total count must be even, like that we have seen each fruit counts, right? So half can go in each basket if you do the half. So let's understand what I'm trying to say here. 1 second. Okay. So if you observe, if we'll swap this one, right, we can swap because it is even, right? This one can go in this one because it is even, right? When we talk about this 2, we have 2 is here also and here also. We can swap it because it is even, right? When it is even, no problem, I'm seeing no problem. You can see 3 is there, 3 is also here, we can swap it. It is also even, right? So there is no problem. Now problems comes in fruit 4 swapping. When we do, when we want to the swap of fruit 4, we are seeing 1. For 5 we are seeing 1. How will do swap it? Because this is coming what? Odd. Remember I said when it is odd, it is impossible. Impossible to do what? Swapping, because its count is coming what? Odd. So half can not go in each basket. If you do the half of, because the count is only 1. If count is only 1, we cannot do the half, right? What is our conclusion here? Our conclusion for the fruit 4 and fruit 5, right? That appears only one time, it is odd, right? So no way to split them evenly, right, in between the baskets. We cannot do that. And in that case, this will give you -1, because it is impossible to make both basket equal, right? I hope you understands it. So now understand the intuition, right? Now you have observed the what the question is saying, that, right? So what is our goal now? Just think, since we want both basket B1 and B2 what? Identical, means equal. If after we can say swapping and the activity, we can say, right? So if both we want B1 and B2 equal, identical, right? This is our goal. What we want? We want both basket B1 and B2 is identical, right? Basket should be what? Equal. If both basket are equal or identical, after you are doing what? That sorting on whatever you are doing here, right? This is our goal. So you should understand the what the question is saying, that we want to make both basket identical. So it is equivalent to split the total count of each fruit evenly. If the total count of the fruit F1 or F2, F3, it is coming even count in the in the both basket in count of B1 and B2. We have to take the count of both, right? If it is coming what? Even, means it is equivalent in splitting the total count that is coming for each fruit, right, between the baskets. If it is happening, then we can make it what? Equal. So this is the prerequisites to do the what? To make the count. If it is not prerequisite, not satisfy, will return what? Just -1, as you can see, right? So can we say that very first we will check even total count, and it is required. Can we say that? So total, so if any fruit appears an odd number of times, right, in both basket that combines, it is impossible. And in that case, we can say it will not split, just return -1. It is impossible. Why? Because it is impossible. We can't split evenly. Okay. This is the our first condition. Then what is the another condition? If we have extra fruit, right, we have to check the extra fruits equal to difference between basket. What is the difference between the basket? So after checking total, right, once we check all the total, let's look at how many extra copy of each fruit one basket has, right? Let's suppose basket 2 having 2 fruit extra, and basket 1 we have seen 1 fruit is extra, right? Because 2 contains 2 times here in basket 1 in B1, remember, and B2 contains 1 fruit only 1 times. Do you remember that the first example that we are seeing there, right? Means after checking total, that is done, what we should check? We should check the extra copies of each fruit. So in B1, 2 was coming 3 times, so extra remain is what? How many? Is 2, right? And in B2 it was 1. So we have to check how many extra copies we have, right? We need to swap these extra to balance it. So if we'll take these two in here, in this one, is it fine? So we'll say take this one, in this what you call uh, B1, right? Now you check, we only need to balance, right? So if it is balance, right, we need the extra of these to balance it. If it is balanced, we are good. Now it's time to think about the swapping, right? That it will make the balance. If we'll make the balance, just find the mean cost, right? Means we'll do the direct swap where we'll take the mean cost, what, A and B. Let's suppose this is A, this is B, we'll do the swapping. But sometimes it's cheaper to use a smaller fruit swap that we have seen, right? So how the means minimum swap is working, right? So we told that if we'll do the direct swap, if direct swap will do, the mean cost is what? Mean cost will become A, if A and B will take, right? So it is saying, let's suppose mean swap is 2 we have, and we'll multiply with the 1, we are getting what, 2. But no, this can be, this sometimes it is become uh, worst in the case of if we can have the cheaper one, right? We'll use the two smaller fruits. We'll just take what, 2 into what is global we have. If it is take 1, it will give you the value. So better you check the global mean and try to do that. Otherwise you can also use the direct swap, just return 1. Let's understand through an example so you'll understand. Okay, give me 1 second. Okay, very first, let's suppose you have the global mean, right? We take the global mean, let's suppose 1, right? And we have extra, so let's suppose 2 and 100 we have, right? Very first step, we do the direct swap, right? We'll do the direct swap. How we will do that, right? So to find the direct swap, we'll say cost, mean will take, and we'll take what, 2 and 100. 2 and 100, what we will get here, we'll get 2, and we say that. Now think, if we'll take the cost and we'll say, okay, if you'll do the mean of 100 and 2, right, what will happen here? Actually we pair the sorted smallest one. So for 100 cost of getting what, mean of this one, so it should give you 2, right? Can we say? But wait here, you should be little careful here. We only consider one side, right? The smallest half after extra sorting, right? For smallest extra, what is the smallest extra? The smallest extra is 2. It means you will take the mean between 2 and 2, will get what, 2, right? So what is the largest extra? Largest extra, you will take mean and will take what, 100 and 2. What we will get here, we'll get 2. But the real calculation is we are taking the global mean, right? For each extra we compare with what, we'll do 2 into global mean, and it will give you 2. So for extra, when we are talking about these two, we are getting what, mean of 2 and 2, and we are getting the value 2. For extra, we are taking, when the larger extra we have, mean 102, we are getting what, 2, right? So total is what, total is 4, right? For example, if you take the example 1 itself, right? Give me 1 second. So let's suppose we, in example 1, what we have seen, we have extra. What was the extra was there? We have 1 and 2. So actually only one swap is needed here, right? 1 vs 2. Can we say that? And global, what is global? You can say global mean, it was what, 1, right? So what is the cheapest, was cheapest mean is there, right? If we'll take 1 and 2, we'll do direct swap. We'll say, yeah, it will take direct swap and we'll give you what the value is there, right? It will come 1, right? But for extra fruit to swap, what we should do actually, we'll say, just if you have extra fruit to swap, just take cost plus equal to the mean, means the fruit value, comma 2, 2 into global mean that we are talking about, this global mean is 1. That will give you the result, and this is nothing but your formula. Understand? So this formula will use in the programming. Okay, I hope you understand, right? So very first, what we need to do in the implementation, we'll use the greedy approach where we'll do the frequency counting. Is very first, what we should do, we will find the count of frequency difference. Then we should do the check. We will check the feasibility. Is it coming? Is it coming not odd, right? So if any fruit is coming odd, we'll return -1. Will not do anything. Otherwise, we'll build some extra element. We'll find the extra element, right? That we will see, and then we'll calculate the mean cost. Okay, so let's try to understand from here. So very first, we have given two things. We have given basket 1 and basket 2 we have given, right? So we will build a count, right? So we'll take a map, has map, and we'll store here. Okay, and we know basket 1 count will get what? N will get from here. Now we have to count the frequency of what you call all the fruits in basket from basket 1, and similarly from the basket 2, right? So we are just taking a for loop. You know, I think you are aware with the for each, right? From each basket we'll get all the fruit at a time, right? And we'll store it, right? And from basket 2 we'll get the similarly basket fruit will get, and keep adding all these fruit B and B. You can say, you can take here, right? You can take A and B also. Okay, so when fruits are coming at a time, right, we will store, we will check the count. If the count is there, right, by default the first time let's say fruit 1 is coming, right, 2 is coming, 3 is coming, 4 is coming, whatever the fruit is there, by default it will give you 0. Otherwise, if you have already stored on the map, it will give you some value, and that value it will get incremented, right? Now when we rerun again in basket 2, we'll do the minus. So we don't need to do the minus again, right? This is just a calculation. If let's suppose how, so let's understand what I'm trying to say. Let's suppose the basket having is example, let's suppose 1, 2, 3 and 4, right? These are the elements we have in the basket. Or let's suppose 2, it was 2, like this we have. Okay, so basket 1 when it starts adding, right, so it will take the map, right? In the map we'll store, very first it will come, let's suppose 1 will come, we'll store, its count is 1, because we are taking initially +1, right? So 1 plus 1 will keep adding, because initial value map doesn't have this 1, so it was 0, so we'll do +1, it will give you 1. Means this is key, this is value, this is fruit and its frequency, right? This is fruit and this is frequency. Okay, next time 2 will come, 2 will come again 2 times, it will increment to frequency 2, right? If it is, let's suppose it's 3 times, will give become, it's 3 here. So 4 it will come, it will come 1, right? Like this. When we apply on the fruit 2, let's suppose basket 2 we are going to apply 2, 1, 4 and 3. Let's suppose, for example, this I'm taking. Okay, very first we'll go 2. Okay, 2 is coming, we have to take the minus, so we'll do the minus, it will become what? 1. We have 1, okay, make it minus, it becomes 0. 4, make it minus, 0. What is coming extra? 3, add it into here, 1 count. I hope you understand, right? Let's suppose if all are equal, right? If all are coming equal, so 1, 2, 2 and 4. Next we have is 2, 2, 1 and 4. If this type of basket we have, right, 2 basket, this is B1 and this is B2. So we know these are the counts we have given. I'm taking together. So very first, when this basket will run through this loop, what will happen? We'll get 1, 2 and 4. All are coming is what? It is coming 1, it is coming 2, it is coming 1. When we apply this for loop, we are doing minus. So what will happen? This 2 is coming 2 times, right? So it will become 0, because first time it will do 2 minus 1 is 1, then 1 minus 1 is 0. Finally I'm writing 0. Then 1 will come, 1 minus 1 will become 0. Similarly, 4 minus 4 is become 0. So this will become all are coming 0. It is even. if any element it is coming extra, let's suppose, right? So that will be the in the map itself. Okay, so that we will apply later. Very first we'll use the has map to count the occurrence of each fruit in basket 1 and basket 2, right? Then we calculate the difference. This is nothing but we are calculating the difference, right? So when we'll do the difference means count in basket 1, right? We are making the minus and we'll creating the difference. This is nothing but your difference. Okay, so once this difference is calculated after the fruit 2 is done, right, you will have your differences here, right? Now we'll check the feasibility. What is the feasibility? Feasibility is if any any fruits total count from basket 1 and basket 2, right, is odd. Let's say 1 is coming. Okay, like in this case it is coming 1, right? We will return just -1. We will not do anything, we'll return -1. So we have to validate. In the next step we have to validate. How we are going to do that, we will understand. Okay, we'll validate this. If it is coming, we'll return. We'll say okay, this is coming -1, so this is not feasible, right? Otherwise we'll build the extra, right? How to find the extra? If it is extra is coming, that we know how to do the do the swapping, those things, right? So we'll take extra by 2, we'll divide, and then we'll find the cost. That we will see. Let's understand here. Okay, so get that. So how we are going to do that? Very first, for all the count from the map you will get the entry set, because this is nothing but to get the all the elements. You check the entry set. For entry set you will get the value as a key. It is a fruit, and the difference you will get, right, all 0 or -1 or 1 or whatever will come, you will get the difference. Now you have to find the mean difference. So math.mean is a thing that we will get the mean. You know, you will get the minimum cost you will get here, right? Just you need to check. If you take the difference and it is not equal to 0, means it is odd, it is impossible. Return -1. Will not do anything extra. From here the control will return -1. You will get the result -1. This is not feasible. This input is not feasible. Okay, otherwise let's suppose everything goes good, right, and it is getting 0, will not do anything here, right? It is not equal to 0, right? Will return -1. If it is giving, because we are checking the sum, even it is even or not. If it is even, right, we'll continue doing we are going to find the extra. We find extra fruit to save. How we are going to do that? We'll check by divide the value. You will take the extra, right? Let's suppose 2 is coming how many times? 2 is coming 2 times. We'll do what? We'll go from 0 to math absolute difference by 2. What is the difference is coming? 2 by 1 is 1 time. You will add extra fruit is coming one time, right? Like that you will get the extras there. So you are building the extra. Once you, and for that you have already created the array list of extra. All the extra will store in the list. Okay, and this is your global mean, right? Global mean will take the max value and will keep updating. The global mean value should be minimum. We are each time we'll update its mean cost. I hope you know how to track it, right? Right, let's suppose it is it's a big integer, infinite value. Now we will get the infinite value, and the fruits minimum fruit is coming, let's suppose is 2. But the mean cost, you will get the some mean cost, right? Means it is 2 or 3 or 1, whatever means the minimum value will get it. Okay, now we have to sort the value, right? Collection dot sort java 8 functions will apply and it will sort the extra. Once you will sort it, right, you will get the values there. Okay, so let's find the once you build this extra, right, you just need to do what? You have to find only need half extra, not the all, and that is why we'll do half extra divide by 2. Okay, so once you find the first half, let's suppose we have some extra is there, like the smallest elements are there, right? You did the half, so only first half list matter, other half mirror doesn't matter. Okay, and for that we'll get the half, and for that we'll check the pairs. How we are going to check the pairs? That we have discussed already, right? Let's suppose for half we'll go to till the half extra will go, means we want to go to half, and we'll find uh, from the half list, right, we'll get the direct swap. Direct means extra at I will getting the direct and we'll find the minimum, which is minimum. So you know the mean cost, you will get mean cost from the whole, and this is a minimum direct, which one is coming minimum. So you can get from extra at I, you will keep value getting the value from here, you will get the minimum value. Whatever the minimum value will get, you will get from the direct value. So it will keep updating your cost. As we have discussed, it will return the cost. Means what we are trying to do here, for each pair, for each extra pair, which is the smallest half, not the big half, right? Just because we have done the sorting, right? So sorting, it will do the sorting. Let's suppose 1 2 3, and let's say 4 5 6 3 there. That's what is unsorted or sorted. So all the 1 2 3 means the smallest value will come in the first array. Let's suppose index, half of the index will become what, smallest element, right? And from there we'll keep checking the extra pair, you will keep getting the direct value, which is your minimum value. So this is to calculate the minimum half, minimum elements, minimum cost from the minimum half elements.